Hey there folks, my name is Michael. I'm an electrical engineering student at Clemson University, and I'm going to tell you how a wheel speed sensor works. Now, normally there will be a gear on the wheel's axle and some sort of sensor that can detect when one of the gear's teeth comes close to the sensor. In this video, I'm showing you an inductance sensor, but Hall effect sensors are also frequently used. So when a tooth from this gear comes close to the sensor, it causes a change in voltage. If you graph these changes as a function of time, you'll get something similar to the square wave shown here. By using some pretty sophisticated computers, we can count the number of rising edges on this graph in a given period of time. Using that information and this equation right here, we can figure out exactly how fast our wheel is turning in radians per second, which is an angular velocity. If we also know the radius of our wheel, we can turn that number into something like miles per hour, which is a linear velocity. And that, folks, is how a wheel speed sensor works.
My name is Michael. I'm an electrical engineering student at Clemson University, and hopefully you watched my last video explaining some of the concepts behind a wheel speed sensor using Hall effect sensors, because in this video I'm going to demonstrate how those concepts can be applied in a real scenario. This is my final project for my ECE 470 class, Vehicle Electronics, and hope you enjoy. See, this right here is my code that's being run on my microcontroller. It works by triggering an interrupt anytime the signal from the Hall effect sensor changes from high to low, or vice versa. If the interrupt is called on a rising edge, the interrupt notes the current time and stores it in the variable called trigger. And if the interrupt is called on a falling edge, it subtracts the time that's stored in trigger from the current time, leaving you with the duration that the signal was high. And it stores that in the variable called width. The width of the pulse is then used to calculate the rotational speed in revolutions per minute, which is then sent to the LCD to provide the operator with some feedback. Alright, let's see how it works. I'm going to go ahead and start my system up just by switching the switch right here on the battery. And as you can see, it shoots up to around 300 revolutions per minute pretty quick. And if I put my finger right here on the wheel and act like a brake caliper and slow it down, you can see that change represented on the LCD. And then if I let go, it'll shoot right back up. Alright, and then if I turn it off, you'll see it slow down. And then after about 2 seconds, it'll reset to 0. And if you take a look at my program, my Arduino code, you can probably see why exactly it does that. So that is a wheel speed sensor using Hall effect sensors. Hall effect sensors are really great in industries, automobile industry, because it works in hostile environments. It doesn't rely on optical image sensing, so if it gets dirty, it doesn't even affect it. It just relies on the induced magnetic field when a magnet passes by it. So really great technology, and that's how a wheel speed sensor works. I hope you enjoyed my video.